Hello and welcome to another Ace Wednesday Whiskey Workshop. Today wasn't intended to be a video, or this setup, quite messy setup here, wasn't intended to be a video, but I thought you might be interested in what goes into our development and thinking process. Firstly, got a bit of a commercial grade monkey shoulder here today. I think it's a blend of at least 8 whiskies, so not quite single malt territory, but until this COVID madness is behind us, I won't be able to afford anything fancy. That's about a nip, I think. That'll do me. Alright, so through the week, I was asked, can we fit our dot shots or double Ds to a Slayer V1? And my answer has always been traditionally no, and I couldn't recall the reason at the time. But then during the conversation I said, yeah, maybe we can use our existing V3 driver board. And then as soon as I hung up I thought, well, no, we can't. And the reason is the Slayer has a 24 volt relay, which is common to the pump, and the first of each reed switches, you can hear it, individually drives the pump. So any one of those 3 switches, the first switch, the most right switch, drives the pump. In the later models, obviously you had a group valve and a group valve relay. We could pick up the signal from that, but the problem is we can't pick up that one signal, if I've got my colours correct. So the relay is pulled high to 24 volts DC, then there's a white wire travels up to the reed switch, and then that is pulled low to ground via the black wire. So can't do it. Immediately texted the customer and said we can't do it, but I'll come up with another way. So what we've done, because it's DC, we have some advantages and some disadvantages. Firstly, and this should be fitted in the factory, all due respect to Slayer, but that's perhaps another topic for a video as well. 24 volts DC, when you energize the coil, it works, it's great, it's fine. But when you de-energize, you suffer from a thing called magnetic collapse, and it actually generates up to thousands of volts at this coil, and without this snubber relay, it can create havoc with the rest of your electronics, and I dare say may have been contributing to some of the problems in the early steam machines as well. But any 24 volt DC load in an industrial piece of equipment, and let's face it, that's what a coffee machine is, commercial coffee machine. 24 volts DC solenoid coils or relay coils large enough will produce, or any size will produce, what's called a magnetic collapse. And what happens is the plunger is accelerating back through. When you turn off the voltage, the plunger is accelerating back through the coil and generating a very instantaneous, very short pulse of, as I said, up to thousands of volts, and that can cause nasty spikes. So anyway, what I did is I just built the circuit basically with the relay only, no snubber diode, and my 3 switches, proving it worked. Then I proceeded with rectifier diodes to split up to each of the 3 switches, and it still worked. And I said, right, now next step. So I built rudimentary versions of our power supplies, driving three shot timers, which they are doing very nicely, and also some isolating signal diodes. So we're picking up 3 separate power supplies, which we can get from the T circuit on the V3s. On the V1s, will have to be a separate 24 volt supply from the power supply, and then there'll be a module, the current module that is supplied for the V3 Slayers, and that'll be modified to work for hopefully V1, V2 and V3 Slayers. Not bad, no ice today. So yeah, that's it. That's basically what we have to do to prove something works before we go to the time and an expense of designing PC board. So as you can hear, the first one brings on the relay, the other two really don't care because it's already on. And each one individually starts and stops the shot timer. So that will head off to production tonight, and hopefully in a week or two we'll be in the web store. So that's all from me today. Stay grounded, everybody, and as always, if you like this format, give me a thumbs up and subscribe. If you've got any comments or suggestions, leave a comment in the comment section below, or give us a shout out on Instagram. Cheers, bye.